looking at my background. Ah! Alright, so now we're starting. Alright, so let's see. So we're going to start today with some fractions here. So basically adding and subtracting fractions. So for the first one, we have 5/4 plus 2/5. So the method that I'm going to show here is a little different from what you're probably used to. I call it the cross multiply method, okay? So the first thing we do is we do 5 times 5, and we get 25. Next, we write whatever symbol is in the middle, we write that here. Then we'll do the other diagonal, 2 times 4, which gives 8. Finally, we're going to divide by the product of the denominators. So 4 times 5 is 20, so we write that here. Then we add the numerator to get 33, and that will be a final answer, 33 over 20. So let's try again, this time with a subtraction. So now we'll start with 3 times 5 is 15, and then we write the symbol in the middle, which is minus, and then 2 times 7 is 14, and then we divide by the product of the denominators. 2 times 5 is 10. So the result is 1 over 10. Now you'll notice that I always do the sort of leftmost diagonal first, and then I do the rightmost diagonal. And it's the same way that I draw my x's, so I never forget. So I do this, and then I do this. That's how I draw an x. So hopefully you draw an x the same way. It'll allow you to remember it. The order is important because with subtraction, of course, the order matters. So if I do 15 minus 4 versus 14 minus, if I do 15 minus 14 versus 14 minus 15, that answer is going to come out different. So that's important. All right, so what if we don't have a bottom number? Well, that's easy. We just put 1 there, right? So, and then we do the same process. So let's see. We'll have 1 over 1 plus 5 over 3. So if we cross multiply, we'll do this one first, which will be 1 times 3, which is 3, right? And then to that, we will add this diagonal, which is going to give 5, and then we divide by the product of the denominators. So that gives 8/3. So next example here, this time you notice that we have a common denominator. So what we do in this case is we maintain the same denominator, and we just subtract the numerators. So then we could, of course, reduce, and the answer will be 1 for that. Okay, so now we're back to the ordinary type of problems here. So we have 7 times 7, which will be 49, and then plus the other diagonal will be 20, divided by 35. So the result for that would be, let's see, 50 and 20 would be 70, so this would be 69 over 35, right? And next one we'll have 2 over 1 minus 9 over 5. So again, we start with this diagonal. That would give 10. Subtract the other diagonal, which would be 9. Divide by the product of the denominators, so we get 1/5. Okay, now here's an interesting problem. So with this one, we don't have a common denominator, but we also don't have completely different denominators. So somewhere in between, right? Now we could, of course, do the same method as we were doing. So we would get 26 plus 8 over 16, which would be 34 over 16, and then we'd have to reduce. 34 is 17 times 2. 16 is 8 times 2. The 2's will cancel, and we'll have 17 over 8 as our final answer. But if you want to avoid the reducing step, there's something else you could do, which is sort of like the more familiar way, where you would sort of multiply by 4 on top and bottom here, and then we'll have a common denominator. So, but since you guys already know how to do that, most likely, I'm just going to leave that out. All right, so with this one, we would get 18 plus 1 over 3. So that's 19/3, right? Over here, we would get 6 from this diagonal minus 3 from the other diagonal, divided by 9. So that's 3/9, which reduces to 1/3, right? And finally down here we get 5 plus 18 divided by 10, so that's 23 over 10, which is good enough. Okay, so let's stop the video there.